Good morning. Good morning. Good morning.
Morning.
Good morning. Good morning. How are you? How are you? Good morning. Turn on your cameras. Turn on your cameras.
With all.
Morning.
Good morning.
Good morning, teacher.
Can you see me clearly? How are you? Turn on your cameras. Don't forget to turn on your cameras. Turn on, turn on, turn on. Good morning, Teacher Namwa. Turn on your cameras, please. Turn on. Okay. I record. Turn on your cameras. Turn on, turn on, turn on, turn on. Turn on before we start. Turn on. Why is the others not turning on their cameras? Everyone, turn on your cameras, please. Can you hear me? Okay. How are you? Where's Pacharamay? Pacharamay, can you put down your camera a little bit? Okay. Turn on your cameras. Can you see my screen now? Can you see it?
Yes.
Okay,
Yeah.
good.
Yeah.
Okay, so we will start now. So first, get your book and open it on page 26. 26. Open your book on page 26. So the topic for today is about the separation techniques. Do you have any ideas about the word separation? 26. Isip ho. Can you see it now? Page 26. Turn on your cameras because I have to take pictures of you. So please turn on your cameras. Okay, so separation techniques. So how do we separate mixtures? Okay, so first, before we separate mixtures, we have to choose a suitable separation method. So we need to consider properties of substances in the mixture. So do you know the 3 types of matter? Do you know matter?
Solid, liquid, and gas.
Very good. So those are solid, liquid, and gas. So before we separate mixtures, we have to know the substances, right? We have to know if it is liquid or solid or gas before we separate. What do we mean by separation? So, you know mixture, right? Mixture is composed of 2 or more substances together. But how do we separate them? We have to remove them equally. Okay? We have to separate to make it like different, solid to solid and then liquid to liquid. You understand? We have to segregate or separate them. Understand? Yes or no?
Yes.
Okay. So first, what is a mixture? So it's a substance made by mixing other substances together. Okay, just like what I've told you, mixing together. Example, if you want to like make a chocolate drink, right? If you want to make a chocolate drink, what's the first one you have to prepare? First, you must have the chocolate and then the milk, right? And then you put them together to make it milk chocolate or chocolate milk. Understand? So you put them together, so it becomes one mixture. Okay? So can you separate milk and chocolate now? No, because they are both liquid, liquid to liquid. Okay? But there are times that a liquid and then another liquid join together and still you can separate them. What are those? Like oil and water. Oil and water, if you put water on top of the oil, what will happen? The oil will goes up and then the water comes down. Understand? So here, separation of solids or solid to solid. So two solid together. Okay? So what are those? Example of this. Okay? So we use sieve to separate large flour particles from the flour particles. As you can see in the first video, they put a lot of flour, right? In the sieve. This is the sieve. Like a small container that has like tiny net. Okay? And then they put the flour inside and then trying to shake it so that the small particles of the flour will go at the bottom on the plate here. Understand? Yes or no? Get it? Okay, that's what you called sieve. This one, sieve. Separation of large flour to the tiny particles of the flour. So after that, when you shake it, the tiny particles will go down and the remaining in the sieve are the large flour, the large particles of the flour. Another, sifting gravel separates it into different sizes. So like this, they put the sand and then after that, the large gravel stays on the sifting. And then the tiny, what's that? Tiny sand goes at the bottom, like this one. Okay? As you can see, all of the tiny particles of the sand goes down. And then the big or the large particles or the gravel stays on top of the sifting. Get it? Next. So in the junkyard, electromagnets are used. Right? Who's writing on the screen? Please stop writing. So in the junkyard, electromagnets are used to pick up scrap metal for recycling. So this one, you know, some are not metals, right? Some are alloys, some are like silver, gold, something like that. So they use the electromagnets. This one is the electromagnet that can pick up and put down the metal materials or the metal scrap. Okay, to segregate them or to separate them from the metals that are not from the other materials. Did you understand? So you look here on the picture. Okay, so the metals like this are picked up by the crane or the electromagnets. And then same like this one, it can move easily from one place to another place. Understand? Hello? Hello? You there?
Yes.
Okay. So here, so magnetic separation is used to extract metals from ores, or metal ores are ground into powder. The powdered ore is placed onto a belt which carries fast magnetic rollers. So as you can see in the picture, if you can see the red one, that is magnetic. And if you see the blue one, that is non-magnetic. So ores, it means like how to say that? Like stone with metals. Okay, so after the stone ground into powdered ore, they will put on the feeder, and then the feeder goes to the magnetic roller. No, the ores are going to the magnetic rollers, which separates the magnetic and the magnetic materials. So if you say non-magnetic, so the stone will go here, and then the metal will go here. Understand? Hello? Okay. Am I clear to you? Is my internet good or not good? Because I'm not sure if my internet is... Again? Okay, let's go now. Next. Oops. I cannot hear you. Okay, now. On page 32 of your class book, please answer this. Okay? So, write down the correct answers. Write down the correct answers. So, a mixture contains of what? A mixture contains of what? Anyone who wants to answer? A mixture contains A, only two substances that are physically combined. B, two or more substances are chemically combined. C, two or more substances are chemically combined. Or D, two or more substances that are physically combined. What do you think is the answer here? Anyone? Anyone? What's the answer here? Hello? Who wants to answer? What's the answer? A, B, C, or D? A, B, C, or D? A, B, C, or D? Anyone who wants to guess or who wants to answer?
C.
Letter?
C.
Okay, so that is letter D. The answer is letter D. D. Okay. That is letter D. Oops. That is letter D. Okay. Why? Because that is, so two or more substances are physically combined. So it is not just one substance. It can be two or more substances joined together or physically combined. What do we mean by physically? You don't do it by yourself. Okay, or you can do it by yourself because physically. Natakan, what's your question? Natakan? Do you have question? If you have questions, you can ask me. Teacher Nama, can you translate it?
Yes, yes.
Okay, what's this? What is Natakan said?
Natakan.
And Wasu?
In chat, right?
Yes, yes.
They just talk with their friends.
Okay. If you have question, just ask me. Okay? If you cannot speak English fluently, you can try. Just try. Try to speak and Teacher John will understand you.
รบ
Okay?
กวนอย่าแชทเล่นกันลูกเพราะว่าทีเชอร์เขาจะสับสนเนาะถ้าจะแชทคุยกันก็ส่วนตัวก็ได้
Yes.
ตั้งใจเรียนค่ะ
I
ถ้ามี
will
อะไรก็
try.
ถามทีเชอร์ตรงๆโอเค
I will try.
โอเค
Okay.
ค่ะ
Okay, next. Number 3. Number 2. Which of the following mixtures can be separated by using a sieve? Remember the sieve? Do you remember sieve? Like the one that we use when we separate the sand or the flour? The one that has like tiny net? That is what you call sieve. Okay, to separate the flour, separate the sand from the gravel or from the stones. So what are the two correct answers here? A mixture of nitrogen gas and oxygen gas, a mixture of water and gravel, a mixture of large and fine flour particles, or a mixture of oil and water. What's the answer? Anyone? What's the answer? What's the answer? Sieve or the sieve. You can open your book on page 29 to know the answer. Page 29 to know the answer. A, B, C, D. Page 29 of your class book, not workbook, class book. Which of the following mixtures can be separated by using a sieve? A mixture of a mixture of nitrogen gas and oxygen gas, a mixture of water and gravel, a mixture of large and fine flour particles, and a mixture of oil and water. A, B, C, D. It has two correct answers.
C.
Again? C, correct. C is correct. A mixture of large fine flour. Again? B and C. Very good. So the answer is B and C. B and C. And last one. Which of the following mixture or mixtures can be separated by using a magnet? A mixture of iron and fillings. That's the, who is Snipit? What's your question? Snipit? What's that?
A and B.
Okay, so A, mixture of iron fillings and nickel coin, a mixture of iron fillings and steel paper clips, a mixture of iron fillings and sand, a mixture of iron fillings and water.
A and B. A and B.
Are you sure? A and B?
Yeah.
Sure? Because iron fillings and paper clips, they are both metal.
C.
They are both metal. And a mixture of iron fillings and nickel coin, they are both metal. A and B are both metals. So the answer is C and D. So you have to separate, right? Iron and sand. So you separate them. And then iron and water, you can separate also. You can get the iron from the water. Understand? So the answer here is C, and D. Understand? C and D. Write your answer or your answers on your notebook, on your book. Are you finished? Are you finished writing them now?
What page, teacher?
Page 32 of your class book. Class book, page 32. Write your answers. Number 1, D. Number 2, B and C. And number 3, C and D. Finish, everyone? Finish? Do you have questions? Question? Do you have question? No questions? Okay, let's go to the next one. So now, separating insoluble solid from a liquid. Okay, so now you have to separate liquid, which is like water, oil, or any kinds of liquid, and solid. Okay? So like this, we can separate insoluble solids from a liquid by pouring out the water. Just like when you cook rice. Okay? So you have to clean first, right? So when you are cleaning the rice, you have to put water. And then how can you separate the water and the solid or the rice? By pouring. Pour the water out of the pot. Understand? Pour out the liquid so the solid will stay in the pot. Understand? Do you do this when you cook rice? Do you do the same when you cook rice? Yes. Okay. Another, we can use a filtration to separate small insoluble solids from a liquid or a gas. So we will use now the filter paper. So when we put example like this one, in the video, you can see it has the muddy water. Muddy water or water from water with mud. Okay? So we put them on the filter paper. So when you put the filter paper here, the water will goes down here and the mud will stay on the filter paper. Get it? Get it? Sure? Okay, next. Like this. So this is the glass funnel. Put the filter paper in it. It has the water and the solid residue. This is what happened to the muddy, like this one, the muddy water. Okay, the muddy water, and then this one. So when the mixture is passed through a filter paper, the solids are trapped by the filter paper while liquid flows through. So glass funnel, you put the water, the solid residue stays here, and then the water goes down. So this is the water. Understand? The blue color is the water. This one, water, water. And then this is the solid residue, or what we call the mud. Okay? Good? Are we good? Okay, so this one, sewage treatment plants use filters to remove harmful substances in wastewater before the water is released into the river. So, as you can see, they use this in some houses. Okay, some houses, I don't know in Thailand if you have this, but this one, from here, this is the land application. Okay, so this is from the houses. Okay, so after that, from this one, from this point, it will flow here. Okay, goes here and then filtered here. So this is the gas. So the gas will be filtered to, wait, let me check. Again, let me see. Okay, so filtered here to goes out here. Okay, and then goes out here also. That's the gas. Okay, so these are the sewages for one house only. Example, for one house only. So sewages, what are the sewages? The poo-poo, right? The poo-poo goes here and then transfer here, goes here, get the gas, go out the gas here, and then after that, clearing the water, and then still clearing the water, and then the harmful substances will be go out or stay here, and then after that, the clean water can go out to the drainage beds or can go to the river. Understand? Do you understand? So this is the sewage treatment. So that it's not really in the river, but it's, how to say that? It's a type of water also, but it's not in the river. Okay, but here, if the water goes out here, it is clean already. Cleaned. Clean water. All right? So the bad water or the sewage will stay here. And then the sewage can go to the land application. This one can put anywhere or can throw anywhere. Okay. Next, surgical masks act as filters also. So keeping dust particles out while letting air to pass through it. Wasu, don't play with your cat. If you want to play, you can play it later. Okay? It's not time to play. It's time to study. So surgical mask acts as filters. So that's why we use mask when we go out now. Not just to prevent us from having COVID virus, but to protect us also from the dust to be inhaled from our body. Okay, because dust is very dangerous also. It can have viruses. Okay, so always wear mask now. Next is, when brewing coffee, hot water is passed through coffee powder and a filter. The filter traps the coffee powder while allowing the coffee solution to pass through. So as you can see, this is the coffee, and then this is the filter paper, right? So they put water on top of the coffee powder, and then the water. After that, the mixture of coffee and water goes down. And then the solid particles of the coffee will stay here. Okay? The solid particles or the big particles of coffee stays here. But the mixture, the color, together with the water are mixed together. Understand? Yes or no? Yes or no? Do you have any questions? Question?
No.
Do you understand all? Okay. Up. Next. On page 38. Page 38 of your book, class book, 38, Samsipet, 38. Page 38. Okay. So which of the following mixtures can be separated by using a filter? That's what you call the filter paper, okay? A mixture of water and tea leaves, a mixture of water and sugar, a mixture of oil, water and oil, or a mixture of dust particles and oxygen gas. What's the
Mixture
answer?
of water and tea.
Again? A water and tea leaves. Correct. Correct. A is correct. What's next?
Mixture of dust particle and oxygen gas.
Very good. So a mixture of dust particles and oxygen gas. So the answers are A and D. Okay, so the answers are A and D. Write your answers on your book. A and D. Finish? Next, which of the following mixtures can be separated by evaporation? What do we mean by evaporation? Do you know evaporation? So by boiling of water, you can separate them. Okay? So next, this one. A mixture of rocks and soil. You can mix rocks and soil, but can you boil them?
No.
No, you cannot boil rocks and soil, right? To separate them. A mixture of water and sea salt.
Yes.
Yes. You can separate the water and the sea salt by boiling them. After you boil them, the sea salt will stay on the pot. And the water will be evaporated. Understand?
เฮ้ยกลับมาได้อาวุธกันปะล่ะกูจะซื้อกระบอกอีกอัน
รบกวนปิดไมค์ด้วยค่ะ
Okay. So the water will be evaporated and then the sea salt will stay. So B is a correct answer here. What's the next one? A mixture of sand and iodine crystals, or a mixture of water-soluble copper sulfate and water?
C.
Again? Letter?
C.
C? Are you sure?
Letter C.
No, it's not letter C. It's letter D. Okay? So water, always remember, everything that you put in the water can be separated using evaporation. Okay? So when you put water-soluble copper and then water, after that, the copper sulfate will stay on the pot. Okay? Or on the, what's that? On the material that you use by evaporation. Understand? So the answer here are B and D. Finish? Everyone finish? Yes or no? Answer me. You can turn on your microphone.
Yes.
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 Very good. Okay. Next one. Okay, so this is the water treatment plant. So from the water or from the lake or from the river, the water goes into the intake pipe. Here, as you can see on the top, right? Here, look. I will make, okay. So here, this is the first stage of water so that we can get water from our house. Understand? So from the intake pipe here, this is the lake, goes here to the preliminary treatment. So the first one to treat water. What do we mean by treatment? To make water clear and to make water good so that we can drink it. Okay? So first, the protective bar screen here. This is the protective bar so that the sand will not go inside. Okay? The sand will stay here and then the water will go here only. After that, it has the traveling water screen. Another screen again. Another screen so that the tiny particles of the sand cannot go. Understand? So the water flows again. After that, it has the 4 low lift pump well. So the water only will goes up. And then the tiniest particles will stay here. The very, very small particle of the sand will stay here. The water will go up and goes to the pre-chlorination. So we put the chlorine. So when we put the chlorine, the water will get whiter or cleaner. As you can see, sometimes when you open the tap, you can see the water color white. And then after that, it has the chemical coagulants. That's what you call it, coagulation. It mixing here so that the water will be cleaner and clearer. So flocculation here, and then sedimentation basin goes back here so that the water will be filtered. They use the filter or sand filter here. So the water will be cleaner, and then post chlorination, they put chlorine again, and then fluoridation. After that, the water will be pumped again so that it can go to the elevated storage water here and can go to the water reservoir and can go to the houses. So in these last 3 stages, the water are very clean now. Understand? In these 3, 1, 2, 3, the waters are good and can be drink or drinkable. Understand? So if you don't understand clearly, I will show you a video of it. Just watch so that it will make you clearer. They will show you the pictures of these stages. Make your, how to say that? Volume up. Up.
home lion daw.
Again. I can't understand. Again?
Cannot hear you.
You cannot hear?
No, no fade up.
No sound?
No.
Okay.
Municipal water treatment plant.
That one.
There are
Okay.
2 main types of water treatment plants, drinking water or wastewater plants. We'll be focused.
Okay, I said already, right? So we have the wastewater treatment and then the portable or potable treatment. So wastewater from the sewages, the water that we poo-poo, right? So the water will be clear here. They will be clean so that they can throw the water. And this is the potable treatment, the water that we drink. Understand? So we will tackle only about this one, the water treatment plant.
Focusing in on drinking water plants here, but if you'd like to learn about how wastewater is treated, you can watch the video.
Next time we will study this. I will make video, or I will download the video of it so that we can watch this also.
Linked in the upper right here. The question still remains, how exactly does one treatment plant take dirty river water or well water and turn it into water that is safe to drink? It involves a lot of processing using chemicals, filters, and removing all of the toxins and hazards from a given source. The entire process starts with something called coagulation and flocculation. All drinking water has to come from somewhere, usually being freshwater lakes, rivers, wells, or streams. In these water sources, there's going to be some amount of sediment as well as organic materials in the water. These particles of sand, bacteria, dirt, wood, etc., they all have to be removed before the water can be sent out to city residents. To do this, chemicals called coagulants are added to the water. These chemicals, such as aluminum sulfate or ferric chloride, work to help the particles in the water congeal together. Essentially, these chemicals have the opposite charges of suspended solids, like clays or silts. When combined, the charges of the particles are neutralized, allowing for them to stick together. Coagulants are often added to the water right at the inlet of a drinking water plant, where the water then goes into mixing basins called flocculation basins. In these basins, the solution of water and coagulant will slowly be mixed together to form what are called floc particles. After mixing for a set amount of time determined by water quality in the flocculation basins, the water is moved to sedimentation basins. It's in these holding tanks where the water sits for the floc particles to begin settling out at a faster and faster rate, which is the intended goal of this process. By simply adding and mixing these chemicals into the water and letting that water sit, a large portion of the sediment will settle out to the bottom as sludge, which can be taken away to a landfill or holding facility. The floc particles are ultimately removed from the bottom of basins, and the clean water, being the cleanest at the top due to the settling particles, flows over weirs to the next stage in the process. In some plants, engineers actually use dissolved air flotation tanks in place of sedimentation basins. In these cases, air is pumped into the bottom of the tanks, creating a cascade of tiny bubbles. As these bubbles float to the surface, they take floc particles with them, forming a film of floc on the surface of the tanks. Then, a sweeper arm pushes the floc into a collection basin where it's taken to a handling facility. In dissolved air flotation tanks, the clean water is taken from the bottom, where the least amount of floc is. When it comes to designing wastewater treatment plants, engineers will vary techniques based on the water source and how they want their final water to taste, feel, or otherwise be treated. The only regulation is the quality of water being pumped to the city, and in most cases, it doesn't matter how plants get the water to that point, which allows civil engineers a lot of creative freedom in the process. After the majority of solids are removed from the water during coagulation and flocculation, followed by sedimentation, the water flows over weirs to the next step, filtration. The water at this point will start looking clear, but there will still be bacteria and very small suspended solids in the mix. The filtration process will seek to remove the remainder of the suspended solids and bacteria to further bring the water up to snuff. Nearly every potable water treatment plant will use a sand filter for this process. Even in plants where engineers may not think it's needed, often sand filters will be added simply for extra measures to ensure clean water at the end. Sand filters are exactly what they sound like, a basin of fine to coarse sand that filters water. It would theoretically be possible to treat drinking water with only sand filters, but that would result in frequently clogged sand filters, resulting in lower efficiency and more cleaning time. These sand filters can be set up in essentially two different ways. Either the water flows from the bottom and exits the top, or the water flows from the top and exits the bottom. Each layout presents its own set of unique problems, but the most common technique is actually actually for the water to flow from the bottom to the top. Sand filters aren't highly technical. Water just passes through them and particles get caught as they run out of space to flow through. However, while not highly technical, sand filters are highly efficient. Water flowing out of sand filters will need to have a clarity of around less than 0.3 nephelometric turbidity units, or NTU. Try saying that 3 times fast. Or whatever local code is used for water clarity. This measurement is essentially just a way to determine the number of particles still remaining in the water, or turbidity. Many treatment plants will also pass water through activated carbon basins, which you can essentially think of as giant Brita filter tanks. Activated carbon particles have hundreds of tiny pores on them that help remove the tiniest of sediment and bacteria. This process isn't wholly necessary, but it helps improve taste and odor, often a desired trait for city residents. At this point, the water should be mostly crystal clear, but there still remains some residual bacteria. That leads us to the next step, disinfection. There are 3 main ways of disinfection in the water treatment process, which can be used individually or in combination with one another, depending upon design. First, chlorine or chloramine treatment, there's ozone treatment, and finally, ultraviolet radiation treatment. In the US, the main method of disinfection is by adding chloramines, or chlorine-based compounds. These compounds, such as chlorine dioxide or monochloramine, work to kill microorganisms. One downside to this process, though, is that these chemicals can react with other organic material in the water to create disinfection byproducts. These disinfection byproducts are harmful to human health and have to be prevented or mitigated. This extraneous reaction with other organic material is also why chlorine disinfection must come at the end of the treatment process. If added at the beginning, an abundance of disinfection byproducts would be created, causing a plethora of issues for the engineers and plant operators. Even with all of this, chlorine is used mainly because of how it kills pathogens. It not only kills any pathogens in the water at the plant, but residual chlorine levels also remain in the tap water, killing any contaminants that might get introduced after leaving the plant. Most cities or states will have maximum or minimum chlorine levels in the treated water in order to keep both the water treated and city residents safe. The other most common method of treatment is ultraviolet radiation. In this process, UV light is shined through the water, which scrambles any bacteria's DNA. This doesn't kill the bacteria, but it makes it impossible for them to reproduce, thus making them harmless. The main downside to this disinfection process is that it isn't residual like the chlorine, meaning that any bacteria introduced to the water after this process can't be treated. Finally, we're left with ozone treatment. This process involves adding ozone, O3, to the water. Called ozonation, the ozone kills the bacteria in the water as well as improving the taste and odor. In most cases, this treatment process also requires that a chemical be used to remove any ozone at the end, such as sodium bisulfate, as not to cause any harmful effects to the city's population or anyone who might drink the water. After the water is treated, in any one of these 3 disinfection processes, it's ready to be pumped into a city's pipe network for delivery to your tap. The water flowing out of a plant is tested for various levels of chemicals, particles, and other qualities all outlined in a plant's permit. This permit, set by the governing agency, regulates water quality and holds the treatment plant accountable in the treatment process. At this point, all the water is fit for human consumption per the permit, and the treatment plant is tasked with keeping it flowing through the pipes in your city. Constant pressures of 40 psi must be kept at the outlets of the water in the system so that in areas of high elevation in the pipe network, the water retains residual pressure. 1 foot in water elevation is directly correlated to an increase or decrease of 0.433 psi. So as water is pumped throughout the city, its pressure at any given point of differing elevation fluctuates. Positive pressure always has to be achieved as to not let any external water in the ground flow through pipe cracks or joints. This would contaminate the entire system and is one reason why you might experience a boil water notice. Essentially, that means engineers have reason to believe that somewhere in that city's pipe network dropped below the required PSI and water or contaminants might have infiltrated the system. Massive pumps at the treatment plant supply pressure to the system through constant operation. Some of this pressure can...
Okay, so I will cut that video because the last part is not part of the filtration anymore. Okay, so we will cut this lesson now here. And we will continue on Tuesday. Understand? So first, turn on your cameras because we have to take pictures. Everyone, turn on your cameras so that we can finish now. Turn on your cameras. Turn on your cameras. Turn on your cameras. Everyone, natakit, turn on. Maria, natakan. Turn on your cameras. Pangsakon. Okay. Show me your big smile, big smile, big smile, big smile. Big smile. Show me your teeth. Feet, not feet, okay? 1, 2, 3, go. Okay. So that's it. See you on Tuesday. Okay? Don't forget to wash your hands. Okay? Wash your hands. Put an alcohol every time. Okay? Okay? When you go out, wear mask. Okay? Be safe. Goodbye, class. Stay safe.
See you again next time.
See you next time.
Tom.
Bye-bye.
Okay, enjoy.
Teacher. I go to sleep. Bye-bye.
Bye-bye. Enjoy.
Bye-bye.
Thank you.
You're welcome.